Alrighty, folks, good to see you. Hopefully, everybody's having a good Thursday. If you're watching this on Thursday, just checking in and popping into this lecture here. We've got a fun one today, so I just want to go ahead and dive right into it. We're going to be talking about a little bit more object-oriented programming here and diving into what's called the Simple Fast Media Library. So the Simple Fast Media Library is the toolkit or environment where we're going to be working in a lot of the upcoming homeworks, which I'm really excited about. I think you'll find them fun and a nice way to apply the C++ that we're learning to just solving interesting real-world problems. So some of these are problems that I've worked on while I've been on the job. Some of them are also just interesting domains where you can sort of visually see what's going on. So remember, our theme of the class is sort of programming in C++, but one pixel at a time. And now we're going to finally start moving towards the actual programming and the visual aspect of the course. So with that said, I'm going to pop out of here for a moment and into our lecture here. So let's just go ahead and dive in. So what I've got for you today, of course we are always recording, for our pre-class warm-up here, just some results for those of you who have completed Module 6 up to this point. If you're playing a little bit of catch-up, no worries, but again, make sure that you're keeping up with the modules. Maybe you'll catch up a little bit today, Friday, or on the weekend. But I was pretty happy to see that most everyone's kind of moving along with the course. And I will just keep checking on this survey. So again, for folks who haven't completed this, please do check in because I want to make sure we're moving at about the right pace. So far, the majority of folks who have answered this think that we're moving at a pretty good speed as far as C++ topics, and I don't want to go too fast and leave everybody behind, but I don't want to go too slow that folks get bored. And summer one's just fast, so I want to be careful here. So thank you for that. And also, it looks like most of the resources have been helpful and really cool to see lots of folks using CPP reference, because that's really the guide that's going to last you, your whole C++ career. That's the one that they keep most up to date. People who actually work on the language contribute that. So that's a really good site here. I'll keep posting the Cherno. Seems like a few folks found that was interesting. If you find him entertaining, of course, otherwise you're welcome to browse and find your own resources. A couple of folks have added Geeks for Geeks, and I'll update this slide as these numbers come in too. And only one person on Stack Overflow, surprisingly. So that was kind of cool to see some of these other resources. All right, so we are, of course, recording. So last time we had our introduction to object-oriented programming. And I started this out maybe in a stranger way than other folks teach it, but I found it's always nice to know how stuff works behind the scenes. Okay, so we looked at an example of doing object-oriented programming where we have a language that doesn't have objects, right? So if you're coming from a Java background, you've probably never seen, or it's less likely that you've seen, how does Java actually implement a class? Same thing in Python. If you're coming from a Python background, from the sort of data science side, what is a class? Why do they pass that self argument into everything? Or same in Java, why do you have the this, dot everywhere? Well, that's the actual pointer to the instance of the object that you have. Okay, so we talked a little bit about that language, and I did a little code dive just so you could see how objects are implemented. That's something it took me many, many years to figure out. So you've got a little preview of that. And it's important, and it'll become important a little bit later on as we dive into more advanced features of the language. Not necessarily for your understanding, but just for, if you really want to do a deep dive into the language to understand that there's just a bunch of function pointers behind the scene. Okay, and then we just talked about, or refreshed for some folks, object-oriented programming, this idea of having member variables, which is our data or attributes, and member functions. These are our actions that our instances of objects can perform. Okay, and then we started building with structs and eventually a class, a little int array example, and showed two of the special member functions, constructors and destructors. Okay, and these were what is automatically called when an object is created or destroyed. Okay, and we learned this term, this sort of weird term, I'll add it here, so that it's in the slide here, this RAII term. Resource acquisition is initialization, kind of a weird term here, RAII, capital I's. Again, just knowing that you don't have any control over this, but these constructors and destructors are called. And even if you don't specify them, you get default versions of them, okay? And then finally, we learned a little bit about const, another usage of const when used with member functions. That marks the member function as read-only for that, for the member variables within that class. Okay, so you'll occasionally see this pop up. It's good practice, and it's a way to sort of protect ourselves from accidentally modifying something. Okay. So with that, assignment 4 upcoming in our course logistics is going to be distributed shortly. It might come tonight for those folks who are watching this on Thursday, most likely on Friday morning. I want to just make sure it's polished up, although I'm going to show you an example of what you're doing. You know, you're welcome to sort of play around with the SFML library. So you know, you will be able to make some progress if you're watching this right now and you have a chunk of time. I'll tell you how to get started and show you what's in progress here. Okay, but before we do that, let's go ahead and dive into and continue our object-oriented programming discussion. And the way I want to start discussing this is something that I learned a long time ago, which was called the Three Amigos rule. Or if you prefer, the Three Musketeers rule. Any pair or triple of things is fine for this rule. And this rule goes along with these special member functions that we were talking about. So again, previously we learned about the constructor and the destructor, and that these two of at least, well, I'm going to show you 3 member functions that we should always define in our classes, okay? So this third special member function is another type of constructor that we should define, and it's called the copy constructor. And this handles what happens when we copy an object, okay, or when we're creating something new. So in this example, let's say I have some custom type here. I have this object1, and I'm creating or passing in an object as a parameter while constructing this object. Well, that means object1 is a copy of object2. Or likewise, when I am creating object1 here, so here's the type, I'm initializing it, here's object1, and I'm assigning it to object2, the copy constructor is also called. Okay, so let's take a look at copy constructor. So let me go ahead and, before I even do a live example, I just want to show you, or sort of set this up in Godbolt, because this is another quick way to see what's going on here. So let's just go ahead and create a really simple class here. Okay, I'm just going to name it simple, and I'll make this public here, and here's this, and it's just going to print out constructor called, and I'll just put an end line. I'm going to make this as brief as possible so that it fits all on your screen here. So here's the constructor. Here's the destructor. It's got that little tilde mark here, so destructor. And then our copy constructor. Well, how do we create the copy constructor? So if I'm trying to figure this out, I mean, maybe we don't remember, right? I've just told you that this exists. So I'm going to do the classic Google, copy constructor. And this is very much a C++ thing, so it's going to show up. And let's go to our favorite site here. CPP reference was folks' favorite, so I'll use this. And here's the syntax for it, okay? So we want to follow this first syntax here. Now, we'll talk about option 2 and option 3 here in a moment here, but this is the syntax. We have our class name, so it's also going to be named just like our constructor, which was called simple, and the destructor, which has a little tilde mark and the same as a class name. Our copy constructor also has that. And then you'll notice that the parameters are const and then class name and then the ampersand, okay? And what this is saying is this is the thing that we're making a copy of here, okay? So we want to make a copy of, well, whatever's on the right-hand side of our equation if we're creating something, okay? So here are the instances here. okay, of where the copy constructor is called. And I want to show you this what's being done here, okay, to show you the sort of three amigos. So when we initialize something, and t here is just abbreviated as some type, and say a equals b, then this copy constructor will be called. Okay, if we're passing in a here, so this is just some type here, then a copy constructor will be called. Because remember, when we pass things in C++ as arguments, we're passing them by value, okay? And then when we return from a function, we are returning a copy here. So this would also give a copy here, okay? So let's go ahead and write this up. Okay, so again, let's go ahead and take a look here. So this is going to be simple, and I almost always, or not almost always, but frequently will forget, what do I put in here for the copy constructor? So again, remember that the thing that is being copied is const, because we don't want to, you know, modify it here. So the thing that we're passing in is sort of read only. It can't be modified, or we can't change the state. And the type is going to be the same as, well, the thing that we're passing in. And we're also passing this in by reference because you can either think of this as, you know, it's more performant to pass in by reference, or the fact that something has to exist if we're passing it in by reference here. So sometimes we'll just name this the copy of the thing that we're passing in, and that's an easy way to remember it. And there is our copy constructor here. Okay, so I'm just going to go ahead and paste this in and say copy constructor called here. Okay, so this is our star here. And I'm just going to, let me just name this T. It's a really boring type here, but that way it'll match the CPP reference documentation, and then you can see what's going on. Okay, so let's just go ahead and create something here. This is our data type here, an A, and it's a very poorly named object. So let's just go ahead and call object1, and then let's see what our output is for this. Okay, so if we actually run this program here, and let me make sure there are no mistakes. It looks like compilation failed because I'm missing a semicolon at line 12. So go ahead and fix this, and we should at least see our constructor called, and there are destructors called when we leave scope in our main function here. Okay, so let's create a second object, object2, and when I'm creating this object, if I assign it to object1, let's see if that copy constructor gets called. And in fact, it does. So we construct this object, that's the constructor called. And then for this one, our next line, well, this object is being created, but it's being created from the copy constructor. Okay, it's making a duplicate of object1. Okay, and this happens during initialization. Okay, so this is what is happening here. Let's go ahead and create another object here, object3, and let's create it from, you know, what if we tried passing in object1 like this, so we get another duplicate here. We will again see for object3, the copy constructor is being called here. Okay, so this is the other instance. Why? Well, it's actually passing in this copy here. Okay, so that is the copy constructor here. And let me go ahead and I'll paste this in so you can see the whole example into the slide, and then you can see the associated 3 destructors being called. Okay, so this is an example of a copy constructor. Now, what if we did something like this, however? Object1 equals object3, because I want to later do assignment. Okay, assignment here. And you'll notice, if you look carefully at this, we have our constructor called, that was for object1, copy constructor called, that was for object2, and I created another version of copy constructor here called. But here, nothing is being done. So we actually have to implement the assignment operator here, and that is going to be sort of our fourth amigo here, or the fourth musketeer. Okay, so if I do a little interlude here, this is the fourth musketeer that we have to introduce, okay? So the idea is, again, from our simple example, we want to expand this so we can also have sort of a fourth thing that you need to implement, and this is the equals operator, okay? So in C++, you can do what's called operator overloading, in which you can overload operators. And what this basically means is you can redefine symbols like equals, plus, times, divide, and so on. And the one we most commonly do, and that's why I call it the fourth musketeer, so the fourth thing that we need to do is do the equals operator, because often we'll do assignment, and often that means copying or performing some common operation. Now it's different than a copy though, because the object already exists, right? If we look at our example previously, object 1 and object 3 already exist. So we need to define the equals operator. Okay, so how would I look this up? Well, let's go ahead and go to CPP reference and do operator overload and see what we find here. So again, there's many different types of operators that we can overload here. So the brackets, the new, delete, and then all of these different symbols here that we can overload. And it's quite a bit here. So let's go ahead and look through this and figure out how do we actually overload something. Okay, and there's got a bunch of different examples here. But this is what we call copy assignment here. Okay, and this is going to be our syntax here. And it's a little bit strange, but we're going to start with this one here. But what we're going to do is we use the syntax operator equal, and then the same sort of idea here, const, and then a reference to the thing that we're copying. They name this as other. I'm going to name it right-hand side, or RHS, just to make it very clear of what's going on. And what it's returning here is a reference here, okay, to whatever the type is, okay, this ampersand here, because the thing already exists, okay, so you're going to see this sort of weird return and star this here, okay, so let's go ahead and just work through that on our example. Okay, so this is copy assignment. Okay, so let's go ahead and dive into this here. So again, our return type is, well, let's start with just the function signature. So operator equals, that's what we are going to be overwriting here, okay? And it's a little bit funky syntax here because you're going to see the parentheses here. And then the signature matches, again, what we had during our copy constructor here, which I'll label here, copy constructor. And so that means it's const because we're not going to modify anything here. And we have, sometimes we call this others in the documentation. I'm just going to call it the right-hand side, which I'll abbreviate RHS, because this is the thing that's sort of incoming. The thing that we're making a copy of here, that's whatever's on the right-hand side. Object 3 is getting copied into object 1, okay? And then we need a return type here. Okay, so the return is going to be a reference to some type T. And this is where things get a little bit interesting here, because what are we actually returning? Well, we're calling this function, or the equal sign is essentially a function. I could wrap it here if this makes it a little bit easier to see what's going on. This is the same thing here. Right, we've got the equals function, and our argument object 3 here is what falls within the parentheses. Okay, so that's doing the equivalent thing. And maybe I'll just write that in the comments so that you can see it here. I'll just keep this here and then get rid of it, because usually you're just going to see it in code with assignment. But this is the same thing here on the right side. So AKA what's here, also known as, or a different way to do it. But what we're returning is, in C++, there's a special pointer called this. And this refers to the actual instance of the object that we're working on. Okay, so this object 1 has been created, and if I want to refer to itself in the class, I can use this keyword. which is the pointer here. So let's go ahead and just take a quick look at this here. And you'll see that it is a pointer. Okay, it's going to give you a little bit of a description of what it is, but it's sort of the implicit, this object exists within itself. Okay, so that's the this pointer. Okay, so again, here's just the help page. Okay, so when we're referring to a pointer, though, well, we're actually not just doing this object here. We need to return an actual object here. So we can dereference and just return the pointer to this. Okay. Now this isn't actually doing a copy here yet. So there's two things we need to do. One is sort of a special case, meaning avoid copying ourselves. Okay. So what this means is if we can do this with a little if block. If the right-hand side is equal to this, okay, whatever this object is, then we want to avoid doing the copy. Okay, now this is the actual object here that we have, but it's not quite liking that. Why? Well, actually, I can make this much simpler here. We could compare the object and see if they're the same. But all we really need to do is just compare the addresses here, or the address of the incoming thing that we're trying to make a copy of and the this, right? This will give us a hexadecimal, whatever this address is, okay? Then we just return. We can sort of exit out early. Let's see, the sort of typical thing that will be done is, actually just return the reference here back to the object, because we're making a copy of ourselves and we have to return this reference here. So we just perform this, okay? And actually that's how we're going to do this anyway here. But now we can actually do the actual work here, okay? And let's just give ourselves a little bit of data here that we want to copy. So, what are we actually doing in the copy assignment or the copy constructor? Well, we'd be setting this dot data equal to, and it's not the dot because we have to, again, dereference. So this dot data equals, well, the right-hand side data, okay? And now we've effectively copied everything from our input here into our object, okay? And we would want to do the same thing. Let's go ahead and just finish off our copy constructor too. We'd say this data equals the copy data here, okay? So this sort of finishes off our object. And let's just go ahead and put a little print statement in here. And let's label this appropriately. So copy assignment operator was called. So we should see that pop up once here at the very end here when we have done our assignment. Okay, so this finishes off this example. So I'll paste it in so you can review, and it is in fact making a copy. Let's just verify by just saying object1 data equals, something relatively random, 77. And we actually need to make this data public here. So this is, let me actually, I want to be safe and show you sort of best practices here. So let's write a little set function here, set data, a value here, and that's going to set our data equal to whatever the value is. So let's just use that function. That's a little bit cleaner, and that'll be a little bit more consistent with folks who have done a little bit of Java here. Okay, and this is object1. Okay, so now if we print data, this will just output the data. And let's actually play around with a little bit the this pointer here, just so you can see the different objects in the actual address. And I'll put a little colon there and an end line. Okay. Okay, so then we will print out the data from objects 1, 2, and 3. And let's go ahead and just to make things, again, a little bit cleaner for folks. Let me see if I can make this just a little bit smaller here. Just so you can see, object1, print the data, and we will repeat this for 1, 2, and 3. Okay, so each time the appropriate copy constructors were called here, so object 2 should be equivalent to object 1, object 3 should also be equivalent. Let's just get rid of this copy constructor here, just to make sure that our assignment operator is in fact copying the data. So we've initialized it here, haven't set the data, but we're just going to reassign it to whatever object 1 is. So the copy assignment here takes place. Okay, so if I run this program, let's go ahead and see what the output is. And let's see. It looks like we are getting 0, 77, and 0. We see that there's 3 different objects, but what's going on here? Is our data not getting copied here? Well, it looks like my order is just weird. So object 2 is getting object 1, and object 3 should be assigned to object 1 here. So let's go ahead and make sure that looks much better here. Okay, so now object 3 is being, because we changed the problem a little bit, assigned to object 1, which has its data as 77. So that looks good there. Object 2, when we initialized it, the copy constructor was called and it's setting to whatever object 1 has, so that was good there. And then object 1, appropriately, we set the data to 77 and it is saved there. Okay? Okay, and I will put this example here in our live lesson here. And you can click on these links if you want to go ahead and just start with this code and play around with it or whatever. That's also fine, as well as it'll be in our repo. So that's one way that we can share the code, and I guess you can change it, I suppose. Okay, so again, just to review what we did very quickly on this. So we talked about the 3 amigos rule. I introduced this idea of the third special member function called the copy constructor, which is called in various situations, such as when it's passed in as a parameter, even during initialization, or when we're initializing a new object and using the equals operator. We looked at an example here, and sort of a tip or a trick is just to use these sort of little cout statements to help us debug. And then we did a little bit of, why, or just understanding how to declare the copy constructor, so why it's const and then a reference type. And then we introduced yet another 4th musketeer, because this often comes up, and learned a little bit about operator overloading, okay, with the equal sign. Okay, so there's all sorts of things that we can overload, but very often we'll want to do assignment, which is the equals operator. Then that led us to learn about the this pointer within the class, so that this, again, refers to the actual instance of the object that's operating. It's just an address or a pointer to the current object. And that's what we're assigning the actual data to when we're doing the copy. Okay, and then here was our full example with the copy assignment. Okay, so with all this copying going on, there's one more thing that we have to look at in memory. Okay, and this is the reason why I was showing you this assignment, but there's something known as a shallow versus a deep copy. Okay, and this might answer the question of, why do we have to go through this trouble of writing the copy constructor? Can't the compiler just figure it out? Well, unfortunately, C++ can't predict how to copy things, especially if they've been allocated with a pointer. Okay, so we have to manually do this ourselves, and this is what's called a deep copy, what we've just done. A shallow copy, on the other hand, is fine for very primitive types. So if I go ahead back to our example here, this is a pretty primitive type. It's a class that just consists of data. So it actually does give us the copy assignment and copy constructor for free. But as soon as we have something more complex, like if I have an array here, for instance, with a pointer, we have to define these copy assignment and copy constructors. Okay, so I guess it's unfortunate for us that we have to do that, but it's also, again, the power that we have control over how copies are made of data, which is an area that you really spend a lot of time in programming doing. Okay, so when do we have to implement this? Well, I just recommend we always implement, right? We've learned about the, it started as the three amigos or three musketeers, but now the four musketeers, right? Having that assignment operator and the copy constructors. It's also very useful when we're debugging to be able to see when copies are being made, so that is super useful. For standard template library data structures, for instance, the things that are provided with C++, they have copy constructors defined. If you do things like this with a vector of strings, you can, just assign them. So you don't have to redefine those in any way. However, where you get a little bit of trouble is if you start having things like vectors of pointers, because you need to allocate memory for those pointers that you're pointing to. Okay, so in general, we always try to implement these. So I want to do an example with, again, just showing the copy constructor with our little int array example where we add the copy constructor and the equal operator here. Okay, so let's go ahead and do that here. So I'm going to make my window just a little bit bigger so that folks can see here. And then I'll split it up. And I want to open up our int array class example. So this was something we looked at last time. Again, just as a refresh, we have this class here called int array. It has storage. It keeps track of its size. We have a constructor here. We have a destructor. And then we have a way to print here, which is going to be useful for us. Okay, and then we can see the size. So let's go ahead with learning what we just learned. Let's create another array here, and let's just make it a copy of this A array here. So when we initialize it, we can initialize it that way, or I can just say it's equal to A. Okay, so let's try to run this. I'll go ahead and grab one of these compile here in the debug mode. So let's go ahead and compile that. It compiles. And if I run it, well, let's see what happened here. Some interesting things happen. We printed off calling constructor, and it's done this here. And then we set B equal to A, okay. And then, okay, B we don't really do anything with. So maybe we should print it out as well. I do B print. Then we finish the program and it says calling destructor, and then we get an error, double free detected in our machine here. Okay, so let me try to recompile this again though, because I want to see if it works. Let me save here with our new print. And it is working. It is copying the array here, okay, because I'm printing out the same thing and we've done the assignment, but I'm getting this double free detected. So what is that? Well, let's go ahead and launch that into GDB, okay? And this is just called prog here. So let's go ahead and take a look at that. And let's step through it. We can't get by too many lectures without jumping into GDB. Okay, so here's next, let's see, next again, let's see, next again, and it prints out. Okay, so I'm hitting Control L to just refresh my screen and get rid of that. Next again, Control L, next again, and it's jumping back to this, which is kind of strange here. Where am I? If I do my backtrace, okay, that's fine. Next line, calling the destructor. Okay, so it's calling the destructor for these functions. That's why it's been highlighted in GDB. Okay, and I do next, and then I get this error here. Okay, so if I do the backtrace, I get a whole bunch of stuff here. But it looks like what's happening is there's a double free detected in our system. So what does a double free mean? Well, if I've assigned B to A during the construction, right, this called the copy constructor, then what that's done is it's done a very trivial copy, meaning all it's done is it said, hey, M size equals the other M size of A and B. And M storage also equals the same storage here. Okay, so let's go ahead and take a peek at this. So what's going on here? Let me go ahead and highlight this line here. Okay, so let me go ahead and get our grid. So what's going on is, let's see, if we don't define our own copy constructor, we get a shallow copy. Okay, so here's what it looks like. We have this object A here, and it's got a size, and it's got its storage. Okay, this is our pointer. And then we've got this other object B here. It's got its size and its storage. And here's just a bunch of memory on our machine. Okay, so when we create A, it's created, somewhere here. This object, let's say it takes up these 2 boxes for the size, or let's fill in 3 boxes for the size here. So A.size is somewhere here. And then this is the storage, for our array, all of this memory. Well, B also, since it's a copy, it gets its own size here. Okay, and let me do this in a different color, just to make it a little bit more clear here. And let me highlight, highlight B. Here we go. Okay, so I'm just going to highlight it in red. This will be our color for B. Just to show it's a different piece of memory. So it gets its own size here. But when I do the assignment here, which I'm doing on line 56, it's doing a really shallow copy. It just says, oh, okay, I'll just, since I'm equal to, I'm just going to assign myself to this same memory here as A, because that's what you wanted, right? You just wanted a copy. And it does sort of the most trivial and simple thing that could happen here. So what happens then, and I'll write this out in a different color here so that we can see, is when the destructor of A is called, then we lose A's storage. And B also points to that same storage. And this is what's called a double free, okay? Because we've already freed this memory over here in our storage, okay? That B also happens to point to. But in A's destructor, right, if we look at A, we're deleting the storage beforehand. So B's pointing to nothing, and it's trying to delete nothing, and it gives us that error. So that's what happened, okay? So we need to fix that by doing a deep copy. Okay, so let's go ahead and fix this. So I'll go ahead and quit GDB, and let's go ahead and implement what we learned here. So our copy constructor, and again, how did we create that? Well, it's the same name here, int array, and it takes in a const and the data type, and it's a reference, and this is just the copy, okay? And no return type for the copy constructor. And let's go ahead and do our copy assignment operator, which we also learned about. And that's going to take in, well, it's the same, or it's not the same, we're doing the operator overloading here, so operator equal. And then the input parameter is the int array. That's also by reference, and I like to use the right-hand side. And it's returning a reference to an array as such, okay? So we're returning this pointer here that we dereference. Okay, so let's go ahead and make sure that this compiles here. So far, so good. And if I run it this time, we still get the calling destructor, and then we're freeing an invalid size here. So we still have to resolve some things. We still have to make sure that we're, in our assignment or our copy, make sure that we are initializing this properly. because now it's just trying to say, hey, don't even call the constructor, don't even construct yourself, call the copy constructor, and we have to set up all of our fields here, because now this is even being called. Okay, so we're still not done yet. Okay, so let's go ahead and set this actual pointer. We want to set its size equal to, well, the thing that we're passing in, its size. Okay, and then we also want to create or allocate the storage for this object. So this object's m storage needs to equal new int for whatever this m size is now. Now, since I've already assigned it, I can actually just use m underscore size here, because for this particular object, I'm setting the size. So I wouldn't have to do this unnecessarily, but I'm just going to type it in as m size here. Okay, so let's go ahead and see how far that gets us. And now we don't have any problems. But now you can see that the copy didn't actually happen, because now we just have zeros all in our second int array here. Okay, so we have to manually iterate through each of the items here. So I is less than size, I plus plus. And then what we have to do is say, well, for this m storage at I, it's going to equal our copies m storage at I. Okay, and then we're doing the one by one copy here, one element at a time. Okay. Oops, it didn't like that because I missed type here, m underscore size. Again, I like to prefix with m underscore so you know it's a member variable. And now we have successfully created the copy here for our copy constructor. Now let's go ahead and do the assignment operator. So I'll go ahead and just comment this out. And let's say that this time we just create an array B, and we want to assign B to A. Okay, so that's the other way that we'll make a copy. Now it's going to complain here, because we need to initialize the size. And let's just say it's only 10 items here. Okay, and we try to rerun this. Okay, now we're still getting a little bit of weird behavior. We have initialized it, but we're trying to do the assignment, and well, we haven't initialized this yet. Okay, so what we need to do here is during the copy assignment operator is first do our special check. So we say if the address of the right-hand side is equal to this, then there's no copy to be made, right? We just return back our object here, okay? Now, the other thing that we need to do is say, well, if our current pointer, so if our storage is not equal to null, that means if it hasn't been created yet, then we need to actually delete m storage. Why do we need to do this? Because we're resizing our storage. So we need to get rid of any storage that did exist in our array before we create this, okay? So let me add a little comment here just to narrate a little bit. If we previously had elements, before we do the reassignment, we want to delete our old memory, okay? Otherwise, we'll leak memory, right? We don't want to just reassign this pointer elsewhere. We want to actually delete it, okay? And then we're pretty much going to follow this same process here, where we're going to set our size to the right-hand side. This size equals the right-hand size, and then this m storage is going to equal new int whatever our new size is. Okay, and then we'll say for int I equals 0, I less than m size, because now they're the same. Then we will set our storage of each element equal to our copies, or the right-hand side, which is our copy, or what we're reassigning to their storage. And remember, we're allocating a new block of memory for our second object. So we're not going to run into this double free error here. Okay, so let me go ahead and save this, and let's see if it works. See if we've made any mistakes. Nope, this looks good here. Okay, so regardless now of what I've initialized this size to, even if it's a smaller object, when I do the assignment, it'll reassign it, reallocate enough space for 20 integers, and one by one assign them here. Okay, so we've successfully done that now with the int array class. So now we have our 4 musketeers here. Okay, so now we have successfully done our deep copy. Okay, let's go ahead and move on here. So you might notice that this project's getting a little bit bigger here. And we're starting to write a lot of code in one place. So I want to organize our C++ project just a little bit into something called a header file. And C++ organizes our code into what's known as the interface and the implementation. Okay, so far, or by now, we have those 3 sort of special member functions, and the 4th one, the assignment, the copy assignment, where we did the operator overloading. But our file's starting to get crowded. So again, in C++, we can separate out our class into 2 types of files, the interface and the implementation. And these are respectively header files, where we have our interface, or sort of our blueprint for the class, and then our source code, which is the C++ files. That's the implementation. Okay, so let's go ahead and take a look at how we do this. So what I'm going to do is I'm going to make a new directory here called project here, and I'll cd into that project, and you can see that it's empty. And let's go ahead and copy our int array class here into this folder. Okay, so that'll put this here, and you'll see that there's just the int array class here. It's the same file here. But I'm going to open this up, and again, what I want to do is move this class into its own file. So that is relatively a clean file that we just have the main, for instance. Okay, so again, let me cd into the project here, and we just have that class here. And I want to go ahead and I'll do this in Vim here so I can split the windows here. Let me split this up here, and let's create the int array class, but the .hpp file. Okay, and this is going to be our interface, the header file. Okay, so let me go ahead and save this. Let me actually do it side by side so it's a little bit easier for folks to read here. There we go. So our interface on the left side, and our implementation will be on the right side. And I'll actually split this one more time, and let's just make a main.cpp file. This is our project entry point, okay? The main file. Okay, so I'll make this a little bit smaller so you can see more of the source code. As such. Okay, so again, what I'm going to do at a high level is I want to move in our interface, that's this class here. So I'm going to go ahead and just move all this here, just cut it away and move it into this header file here. So just paste it in here. This is our main, so that's going to go into our main file. And if you're getting a little bit lost here, you can see main.cpp here. Here is our header, and this is where our actual implementation is going to go. Okay, so let's go ahead and just label this our implementation. Okay, so how can I refactor this? Well, I want all of our blueprint, the class here, to be in this interface file, this header. Okay, so I'm going to cut all of that out and paste it in here. Okay, so now we can see all the work we've done, all the code is here. Okay, and we'll move all this other sort of setup stuff here. I'll move this into the main. Okay, so now we can see that there. Okay, so here's our main file. It doesn't have too much to it so far. Okay, so what I need though in my interface or my header file is all of the member functions. So I need our int array, and this is the size. So I'm just going to copy or retype out all of these names here, and that just serves as our blueprint. These are the declarations here. Okay, int array, then we have our copy constructor, int array const int array takes in a copy. Okay, and I'm just matching them and then terminating them with a semicolon. And int array, the reference here, operator equals const int array, and that was the right-hand side. And then what else did we have here? We had our print and our get size functions. Okay, so that was return type of void and print, and then int get size, and that was a const like this. So now it's actually pretty neat if we look at this. Our interface here on the bottom left, it's a really compact file, and it gives us a high-level overview of all the things that we can do in our project. Okay. So what else can we do with this? Well, this is a header file. So like we've been doing, for example, when we include IOStream, we can include, and we use quotation marks to include here, our int array class.hpp. And this is the file path from our main file that we can get to. So if I look at my structure here from the main file, that's this C++ file here, I'm including a file in its same directory. Okay, if it was in another path, for instance, you might have like /home, /Mike, and then the file there, that's how you would include it. But typically we just put in the relative file path. So how do I get to that file from this main file here? Okay. Okay, so we have that available to us. Now there's a few other things we need to do. We want to guard this file so that it's only included once. Because what I'm including, and we're going to talk about this a little bit in the next module, I'm basically copying and pasting this file here on the left side, the header file, and pasting it into here. That's how it knows that this class exists. So what I do is I put something called a header guard here. And I name it just whatever the class is, and I write it in all uppercase, so int array underscore HPP. And I define this symbol. And I say if it's not defined, we'll define it here. So it only gets defined once. Then I have an endif. So this is essentially an if block that defines a new symbol here. And we'll talk about how this works in the next module or two. And it protects this file from being included multiple times. Okay, so let me go ahead and save that. And then, well, within this class here, where these functions are, we also need to include our blueprint because it's defining them. So I need to include our int array class.hpp. Okay, so let me go ahead and just paste that in there. And that's what we have. Okay, so at this point, let me try to compile this and see what happens. Okay, so we are going to paste this in here, and I'll run this, and we get a ton of errors. Okay, so there's a lot going on here. There's two things going on, at least two. One is we have two files that we're compiling now, our C++ files. We don't compile our HPP files because those are just, again, copy and pasted into other C++ files, so they will eventually get compiled. So main CPP and our int array class CPP. So let me do that and see if there's less errors. Well, there's still a bunch. And if you look through these, you'll see a lot about this thing called scope. Scope is not there. Doesn't, request for member, it just can't find these functions here. And why can't it find them in int array? Because it doesn't know the scope or where this function belongs. It thinks it's just a regular free function. So what we do in C++ is we add the scope operator, which is : and then the name of the class in front of it to say, hey, within this class int array, which is over here, you'll find this function int array in the constructor that takes in one parameter for an integer size. Okay, so now if I add those in front here, int array : I'm going to do that for all of these, just so you can see me. Int array, the scope operator, so what scope I can find that function. Int array, and then : again, where I can find that function. I do this one at a time. And then again, int array, colon. You'll notice this time, this is the scope where you'll find the function, but the return type is after. Okay, that's how we do that and set up our class. Then again, int array, and then colon, get size. Now if I try to compile this, it looks like I only got one error here. And let's go ahead and see what that is. And it looks like for my copy assignment operator, I just did things backwards here at line 35. So in front of the operator is when we do the int array in the scope here. Okay, so let me go ahead and save that, recompile, and we get our same program. Okay, so this is the sort of project structure here. So I'm going to go ahead and I'll paste this into the slides. You've seen the sort of live example here. But if I go ahead and maybe it's useful to sort of just highlight where you can see the header file being included in the files that are using it or otherwise implementing the blueprint of our class. That is the interface here. Okay, so let me go ahead and just label this as well, that this is the file int array class.hpp so you can see it. Okay, it's probably more helpful for those of you who are following along in the live than to just look at the screenshot, but this can be a reminder of the general structure that you have for your project. Okay, so here it is for you to take a look at here. I'll make it as big as possible so you can actually see it in the slide if you're just following along at home. Okay, and this is a good one to try to take that example if you've been following along and just break it out into a separate CPP file where you have the implementation, the HPP file or the header file where you have just the sort of blueprint of the class. And this is nice and easy because you can just see all the member functions and member variables available, and then actually using it in your main. Okay, nice example. Okay, so we're nearing the end here, and I want to just wrap things up, but I want to give you a break if you need it, and then we can continue moving forward here. So if you've gone ahead and give yourself a little break here, let's go ahead and wrap things up here. And I want to talk about getting you ready for the homework. Okay, so for the next assignment, as I mentioned, we're going to be starting to do some pixel operations. And as I mentioned, and I can bring myself back in here in a second, that this is the real fun part of the class where we get to start doing some of the pixel operations. But it's going to take a little bit of setup. So for folks who have lots of C++ or C experience or coming in with some, this will be pretty familiar. For new folks, I want to give you an alternative option if you've been struggling just getting things set up. Okay, so let's go ahead and take a look at what can be done. So you're going to be using something called the Simple and Fast Media Library. It's called SFML. And it's used a lot for games, you can use this for Android, iOS apps. It runs on Windows, Linux, or Mac, so I know that everybody in this class can feel supported. And there's a really nice Learn section for the tutorials that'll help you get started on whatever your environment is. So we have some folks on Linux, some folks who are using Mac, and you can use Xcode or whatever. And there's a couple different options here. But I want to sort of give you an option to just set things up as easily as possible. So what this means is using a tool called VirtualBox. Okay, and VirtualBox is a way to emulate the Linux environment. That's the same environment that I'm using to run your labs in. Okay, so VirtualBox allows what's called virtualization, which lets you run an operating system within another operating system. So this is a Windows background, and you can see Linux here in this window. This is a Mac, and you can see Linux running here. Okay, so there's a few ways to set it up. VirtualBox is the popular thing to download. There's also VMware. That's the application that's running the operating system. And for Mac folks, if you have a new Mac as of like 2020, there's another newer virtual environment that you can download or try this one. Okay. So let me go ahead and show you this for your next homework here. Okay. So what you're going to do is launch an application. If you're doing this in VirtualBox, I at least want to show you how you can get this set up. And let me actually just open up the lab here, or excuse me, the homework. And I've provided some instructions here about the virtual machine and sort of getting set up here. And you'll have this, so basically you'll click this link. It's a 9 GB download, but it's the whole operating system and all the libraries and everything installed, and you'll have that. And then you can download VirtualBox from the downloads. So this is what I recommend doing. This is what I'm going to show. And if you're on Windows, you download the Windows host, or the OS Mac, you download this one. If you're already on Linux, you don't really have to do anything, but you can use the environment if you like. Okay, so once you have that installed, whether it's VirtualBox or VMware, then you'll go to File, Import Appliance, and you'll import my virtual machine here. Okay, and once I do that, it'll launch the virtual machine here. So you're going to see an operating system within an operating system, which is pretty cool. And so I'll just take a few moments to load here because it's booting up an operating system from scratch. Again, it's pretty cool here. And the let's see, the username and the password is just user for user, so you don't have to worry about it. And then you'll have this entire environment available to you. Okay, so I'll just give it another moment to launch. So I've given you a little bit of some messages to read, and there's also a notes.txt that you can open and read along for just some notes here, say for programming C++ here. Okay, so what you can do here is two things. One is use the web browser here and navigate to your GitHub repository, so wherever github.com, and whatever your repo is, so you have to type that out, and you're in the virtual environment, and then you do a git clone of, my repo, and that'll copy the repository into this environment here. Okay, you can do xdd-open and then a period, and that'll open up the folders if you prefer to see the sort of folder view, or you can navigate by just clicking on files here and sort of also navigating around. Okay. And so what you'll do is, and I'll show you a few commands, ls just to list out where you're at, cd if you want to move to some location, cd to go back home, pwd shows you your current path, and so on. Okay, so those are just some, getting started with a terminal if you want. I've also installed an IDE if you would prefer that, CodeBlocks here. So you'll be able to work in projects in this way if you like, if you find that easier. Okay, and yeah, sure. So this is the Linux environment, right? And then when you're done modifying your files, you do git add, whatever the file is. You'll do a git commit and then a message that's useful, made some edits to A4 or whatever. And then if you do a git push, that'll push to your repository on github.com. Okay? All right, so let's get to actually running SFML though. So for anybody using the VirtualBox option, I've included their hello world here. So let's go ahead and I'll use tmux here and split the window. And let's go ahead and open up that SFML example here. Okay, and I'll make it a little bit bigger just so you can see everything. And it'll get a little bit stretched out here. But this is the basic example that's been provided here. Okay, so I can scroll down here and you'll see a window. So I've included a line here to compile. Okay, and let me go ahead and just type it out and I'll read what's going on here. And let me shift it here so you can see it all in one line. So we have a compiler. I've already installed G++. It's a recent version, so you can use C++17. The file that we're compiling is SFML, and we want to output our program here. If I just hit enter here, it's going to give a bunch of errors. It's going to say undefined reference to SF : render target. So what we're doing in this code is we're including the SFML library here. That's a header. So we just learned about including headers a little bit. And it's in the SFML graphics library. And it's got all of these classes that they've created for us. So all their custom types to do various graphics work, like rendering a shape. Okay, so there's a, within the SFML library a circle shape, okay, within this scope here. But what's going on anyway during the compilation phase is saying, hey, we didn't find all those things. Well, we actually have to link in the library, okay? So when we compile, we type -l, and you'll see the library. So -l means link, and then what follows with no spaces is the library name. Okay, so -l sfml graphics, -l sfml window, -l sfml system. Okay, so this will bring in all the libraries that have already been created and provide the functionality that we need for this program. Okay, and if we run it, you should see a little simple program like this, and then you should know that you're set up for the semester to work with this library. So I recommend this VirtualBox environment because it's been set up for you, and it'll be relatively easy. But if you don't like this, and I'm just going to close the terminal and then shut this down here. The SFML tutorials here for just learning in general are pretty good. So there's the getting started section, and then you can take a look at some of the stuff like how do you draw 2D things, okay? And I'll provide some of those resources. Those will be part of your assignment 4. Okay, so getting to that, the assignment 4, what you're going to be doing here, and let me go ahead and just run this. I have a little build script here, and this will run my program. Is, yes, I put myself to it again, but you're going to be building some image filters. So you get a default image, and you're welcome to change this to whatever you want. And if you press the 1 through 7 keys, you'll notice different filters being generated. Okay, this one's a blur. It's a little bit hard to see between these two. I'll flip through them a couple times. Here's another blur at 6, and then 7 is a little edge detection. Okay, so you don't see all the edges here. And these are little filters that you can write, and you're welcome to add your own. So for folks who want to explore this more, that will be your assignment. So that's what's going to be coming here. And you can do that within the VirtualBox environment or on your machines by following these instructions. But I strongly recommend the virtual machine. It'll make things a little bit easier for folks. But you have some options here. The Linux instructions are what was followed on the virtual machine, and it works really, really nice. It works really easy. Okay, so with that said here, let me return to the slides to just give you your reminder. Again, to look at the SFML materials if you find those useful. And for folks who are watching this, are going to be watching this soon, we'll see you Thursday in the live session on Teams in the general channel. We'll just have sort of a group discussion to catch up on things. Otherwise, everyone, I hope you have a good weekend, and we'll talk super soon. Keep visiting in office hours. Those have been great. Keep coming to Piazza and asking questions, especially as we're getting set up with the SFML stuff. If you're having difficulty, the VirtualBox is the way to go. It'll make things easy in the class, but you're of course welcome to try other options if you prefer that environment. Okay, so we'll see you and talk super soon.